fellow mathematicians. This is Ms. Backfish, and I am here to talk to you about, in our book or in our class, this would be lesson 1.3. This is in a particular college algebra class I'm teaching, and it's titled Formulas here. So let me also be general though, because this is also sometimes called literal equations. And basically what this is it's when you are given an equation that might have numbers in it, but it has a lot of letters. It has more letters than numbers, really. And you aren't solving to get a final answer like x equals 3. You are solving for one of those letters. It will always say something like solve for M or solve for B, meaning you're trying to get one of those alone on one side. So I'm going to give you an example, and this is the area formula for a triangle. And let's suppose that I wanted to use this to find the base of a triangle if I know the area and I know the height. In other words, I know the A and I know the H and I want to find the base. Well, I could just as easily plug it in this way, but what if I'm doing a lot of problems like that and they all have the same missing information? And so I'm always plugging in H and A and I'm always trying to solve for B. It might be more convenient if I just change the entire equation to where it's set up to be solved for B. Excuse my shuffling here. So in other words, I'm going to solve this for B. And all that means is I'm going to get B alone on one side of the equation. So I'm going to start out here, and I'm basically using the same rules we use for solving an equation when we do want an answer like x equals 3 to move things away from B. Remember that whole do whatever you want to do as long as you do it to both sides of the equation. Do unto one side what you do to the other. So for instance, I could get rid of this 1/2 by dividing by 1/2, which is the same as multiplying by 2. So I can multiply both sides by 2. I kind of squeezed it in there. And then 2 times 1/2 just makes a 1. So now I just have 1 times B times H on the right. So now the right-hand side says 2A equals B times H. The reason I knew I needed to do that was I needed to get rid of the 1/2 and it's multiplied times the B. Okay, so that means dividing by 1/2. Dividing by 1/2 is the same as multiplying by 2. Now I have another thing being multiplied by B, or B is being multiplied by something else. It's being multiplied by H. All right, so I need to get rid of the H. I have B times H. To get rid of that, I'm going to divide by H. Now B is alone, and so we usually like to write the one that's alone on the left-hand side. So I'm just going to turn this around and say B is equal to 2 times A all over H. And that's my final answer. That's as far as I need to go with this. I'm not going to get a numerical answer. I'm just trying to get whatever it asked me to solve for alone on one side. And so that's how you know when you're done, is when you've done that, when you've managed that. The reason I wanted to start with this example is because it answers the question, why is this lesson called formulas? Because that's where we use this skill the most, is when we're dealing with formulas, because formulas very often have more than one thing that we might need to plug in. And so you have multiple letters. You have a lot of letters going on. And that's really the only reason this is called literal equations. It's almost like literature, is that I have more letters than numbers to speak of, to a certain extent. All right, so I have come up with a bunch of other examples that will allow us to explore some of the other things we might have to do to get a certain variable alone. None of these are really formulas. None of these are specifically formulas. I just made them up out of nowhere and picked some letters. Okay, so let's start with this literal equation. It's not a particular formula, it's something I just made up. But you might see something like this, and here it says solve for D. So that basically just means I want D to be alone on one side at the end. So I've got to move this other stuff away from D. Whenever you're solving an equation and you're trying to isolate your variable, you're moving other things away from it, you start out basically farther away from the variable, moving the things that are farther away from it. So in other words, I'm going to start out by moving the C, not the things that are right there in the same term with it. Another way of thinking of this is we're going to start out with moving anything that is added or subtracted to our term, and then go to multiplication like between the d and the g. So this is a positive c. I can get rid of it by subtracting c. So now the left-hand side of my equation says a minus c. And the right-hand side of my equation says, don't forget this is still here, negative dg. Okay? Now the d and the g are multiplied, so to get rid of the g, again the goal is to get d by itself, I'm going to divide by g. Divide both sides by g. And when I do that, the g's will cancel. They become a 1, so it's just the opposite of d times 1. And this side is just as it is. That might be the hardest thing about these, is just letting yourself accept that we can't simplify. We're just going to leave it the way it is. All right, and where does that get us? That gets us right here. The last thing I need to do is, if I am asked to solve for d, I can't have a negative in front of it. D has to be 100% alone, just like 1d. So I need to get rid of that negative in front of it. The negative in front of it is like a negative 1. So I could either divide, or really I could also multiply by a negative 1. In this case, I think I'm going to multiply by negative 1. It's the same as dividing by negative 1. Either way it works. It's just that I don't want to confuse you with, over here we have a fraction when we divide it by negative 1. But let's multiply by negative 1 first. Okay, and then on the right it's going to be d. This is really the same as dividing by negative 1, because, let's talk about why. If you divide by negative 1, that's like dividing by negative 1 over 1. And when you divide by a fraction, that's the same as multiplying by its reciprocal. Multiplying by 1 over negative 1 is the same as multiplying by negative 1. So all of these are the same. Okay, so back up here, what happens here? We could put, there are a lot of different ways I could write this. I could write negative outside of the a minus c on the top over g. Notice that it's not, when you're multiplying by negative 1 on a fraction, it's not negative 1 on top and negative 1 on the bottom, because that would have the effect of canceling itself out. This is just negative 1 on top, because remember, that's just like it says this. And top times top, bottom times bottom is how we multiply fractions. All right, so you could say it like this. What we would generally do is we would go ahead and distribute that negative. So in other words, I'm going to apply it to the a and to the negative c, and say that d is equal to the opposite of a when I do negative times the negative plus c all over g. This is how I think I would leave it. There's a little bit of wiggle room there in terms of how various people, different people doing this math problem would end up deciding to leave this, where do I stop? As long as d is by itself on one side, you're pretty close to done. It's just a matter of how do I want to simplify the other side. And again, there's a little bit of wiggle room. There are different ways you could do it and still be correct. I think the most two common would be like that or like this, leaving it like one of those. And actually, let me show you one other one that would be common, now that I think about it. When you have a fraction, a single fraction, with one term in the denominator, and that doesn't mean just g, it means it doesn't have any pluses or minuses. It could be 3g, it could be gh. It's just something in the denominator that doesn't have pluses or minuses. But on top, we do have pluses and minuses. You can split that into two separate fractions. We could say, and that's a bad marker, we could say this is equal to negative a over g plus c over g. Those mean the same thing as well. So that's another way you could write this one. All right, next up. Again, this is not a real formula that we use for anything in particular. This is just something I made up so that we could practice the skills we need in order to solve literal equations. And this particular one tells me to solve for n. You do have to be told in problems like this what you are being asked to solve for. There's not just one general way to solve them. It's a matter of you are being asked to isolate one variable, to get one variable alone, and you need to know which one. All right, so I'm trying to get this n alone. I think the first thing I'm going to do is I'm going to get rid of these things outside the parentheses. So to get rid of the 1/3, I'm going to multiply by 3. This becomes a 1, so I don't even have any of that anymore. It's like it's gone. It just starts with m on the right-hand side. So let's rewrite that. Next, you could distribute here, but I would rather not. And that's because what I'm trying to get by itself is inside the parentheses. If that's the case, it's quicker or more efficient in my mind, and it still would work if you chose to distribute here. But it's quicker to get rid of that now. In other words, m is times all of that. So divide everything by m, and it will go away. So now I have 3p over m equals n plus s. So now we are right down to the finish line. The only thing preventing n from being alone is that plus s. So I'm going to subtract s, and there's not really a good place to put it. I'm going to put minus s here. So let's rewrite it. 3p all over m minus s equals n. And there we go. Next one. And remember, you can always pause the video and try it, and then see how I do it. Okay, so pause the video and give yourself a chance to try this if you'd like. This one's being solved for x. So the first thing I'm going to do is get rid of this, the farthest thing away from the x. Notice that it was a little different here with the parentheses. This wasn't necessarily the farthest thing away from the n. Nothing really was, but it was outside the parentheses. So in terms of the kind of a peeling back the layers of an onion, it was farther away from the n. So here I'm going to subtract p from both sides. This is one way to do it. There's actually probably a quicker way. I'm not sure if I want to do this. What I'm noticing is that p is in both terms here. So I could factor out the p. Let's do it without doing that first and see what happens. Now I need to get x by itself. So we can go ahead and take care of that negative. I'd like to do that now. So this is times -1, and this side's times -1. So that gives me negative m plus p equals p times xy. Then I'm solving for x, so that needs to stay put. I can divide out the p, because that's times the x. And I can also divide out the y. I can do two steps at once if I want to here. So divide by py. And what happens here is the p's cancel, the y's cancel, and x is alone. So I'm going to write it over here. X equals, I would probably write this, change the order here, because we don't really like to start with a negative. So even though I did that in another problem, I would probably, when I multiply a subtraction expression by -1, I usually just turn around the subtraction. That means p plus -m, or p minus m. So p minus m all over py. And there we go. Let's look at what it would look like, and it would be equivalent. It's going to look a little bit different if I had factored out the p to begin with. So let's go through that pretty quickly. The first thing it would look like is this, when I took out the p out of both terms. There's a p here, there's a p here. Take it out of both, and it comes out front. So now I can get rid of the p, and I have m over p equals 1 minus xy. All right, let's subtract the 1 from both sides. Subtract the 1 from both sides, and we get m over p minus 1 equals negative xy. I'm going to multiply by -1. Okay, so that gives me negative m over p. -1 times -1 is +1 equals xy. And then the last thing I need to do here is divide everything by y, and x will be alone. Dividing this whole thing by y, when you divide a fraction by something else, basically that just pops into the denominator. So dividing the negative m over p plus 1 by y does this. Now, that looks different. That says equals x. That looks different from this up here. Which one's right? They both are. Because remember we said if you have one term in the denominator and two terms on top, you could rewrite that as two fractions. Look what happens when I do that. P over py minus m over py. This becomes a 1. 1 over y minus m over py, which is the same thing as this, just written in the opposite order. Negative m over py plus 1 over y. So these are the same, and again, I would accept either one. And your Pearson software is actually pretty good about accepting it written in different ways. But there are different ways you could write it when you have x by itself on one side. All right, moving on. I'm glad we talked about factoring out the p in the last one, because look, here we have two terms, 1, 2, that both have a q in them. Not only that, they both have a 3 in them. So let's see. If I'm going to solve this for, there's a lot of different ways I could attack this. But if I'm going to solve it for q, I think I'm just going to take the q out. I'm not going to take the 3 out. I'm going to say, okay, this is q times 3r plus 3t. Now, why didn't I bring the 3 out? Because I'm trying to get q by itself. That's the whole goal here. So I'm going to move it. When I move it out, I've already sort of isolated it a little bit. It's not alone on the whole side of the equation, but it's sort of alone out in front. So that's kind of nice. I'm headed in the right direction. Next thing I can do here is this is q times all of this, so I can divide by all of that on both sides. This is going to become a 1, and q is by itself. So I have q equals f over 3r plus 3t. Another way that could be written is f over 3 times r plus t. Either one of those is fine. Q's by itself, we have solved for q. All right, last one, and this one's a little bit of a curveball. So let's look at this one. This is a little different. Okay, this is a rational equation. I've got fractions, and specifically I have fractions where there are variables in the denominator. So what I'm going to do here is I'm going to do that thing that we did back in the first few times we were solving equations with variables in the denominator. We said, let's figure out what all the denominators divide into. What is a common multiple, a least common multiple of all three denominators? Well, E, H, and T don't have anything in common. When that's the case, then your least common multiple is just the multiple of all of them. In other words, E times H times T. My least common multiple of E, H, and T is going to be EHT. Once you figure out what is the smallest multiple of each one that they all go into, the least common multiple, all the denominators go into, we're going to multiply by that in every numerator. I'm multiplying every term by EHT. And I really only need to do it on top because EHT is the same as EHT over 1. So the over 1 means the denominators aren't going to change here when I multiply by that. So it's times EHT times EHT times EHT. Now the reason we did this is about to happen. I'm about to get rid of all my denominators because now I have an E over an E. That's a 1, so that's going to get rid of that denominator. I have an H over an H. There's a 1, gets rid of that denominator. And I have a T over a T. There's a 1 also. So now what I have is HT, that's what's left here, equals ET plus EH. Now I'm going to go back and look at this. I'm solving for T. Right now I have T's on different sides of the equation. That doesn't help me. If I want to solve for T, all the T's have to be on the same side because I have to be able to get them alone on one side. So the next thing I'm going to do is I'm going to subtract, I'm trying to find a different color here, subtract ET from both sides. That gives me HT minus ET equals EH. This became 0, so it's no longer there. And now I have a T, I have a T in both of these terms, and so I can factor it out. T times H minus E equals EH. And last but not least, I have T times that set of parentheses. So to get rid of that set of parentheses, I divide. And T is equal to EH over H minus E. And that is my final answer. I hope this has helped. Let me know if you have questions you'd like to ask about this, and I will see you next time. Thanks for coming.